Now here in this video we're going to look at our intercepts and symmetry as well as looking at sketching the graph of your equation. So I want to start off talking about our x-intercepts. And our x-intercepts are simply where your graph crosses the x-axis. And you think about this graphically, if we're going to cross the x-axis, any point here, what do we know about the y value? Well, that means we cannot go up or down. So if we're not going up or down, that means your y value must be 0. So your x-intercept will always have the form of a number and then comma 0. And then when you're looking for your y-intercept, notice then we're looking for a point that falls on the y-axis. So therefore, your graph is not going to go left or right. So your x value is going to always be 0. And then you would have some number for your y. So this is the form of your x and y intercepts. For an example, if we were to have the graph of a straight line here, then your x-intercept would be located here at this point, and maybe this location is over 3 units. And then, of course, you're not going up or down, so the y is 0. Where on the other hand, this point here that crosses the y-axis, we know it has to be 0 for x because we're not going left or right, we're going straight down, and maybe that's located at -2. So there you would have your x and y intercept. Now the next thing we want to look at is our symmetry, and we want to look at symmetry with the y-axis, the x-axis, and the origin. So if we start off with symmetry with the y-axis, what that really means is if you have a point xy, okay, where x and y could be representing any number, then if it's symmetric with the y-axis, then that means that if you take the opposite of your x value, your y value is going to remain the same. And we looked at an example of this in a previous video. For example, if we have the graph of a parabola, for example, let's say our parabola looks something like this, then what this is really telling us is that if we have the point xy, and we'll just say here's a point here where x is positive and y is positive, then if that point is on the graph and it's symmetric with the y-axis, then that means that the point, when your x is negative, you're going to get out the exactly same y value. And that's again because you could fold your paper along the y-axis. So therefore, the x and y point would fall right on top of the negative xy point if you were to fold your paper on the y-axis. And similar, if you were to pick a point down here, we could pick a point down here as well. And this means what? Your x value is positive and you have a negative y value. Well, then that point then would be reflected over here, which again, that means you would have the opposite of your x. So the opposite of x would be negative x, and the y is negative, so it's going to remain negative. Okay, so that's kind of graphically looking at your symmetry with the y-axis. Now, if we want to look at your symmetry with the x-axis, then again, if you're given a point xy, then this is going to be just the opposite. That means that your x is going to remain the same whether you have a negative y or a positive y value. And you probably could guess this a little bit, then that means that your graph is going to look like a parabola, but in this case it's going to be a sideways parabola. It's going to look like this, where once again, if this is a point xy that obviously falls on the graph, then if we have the point x negative y, then that point would be down here, where even though your x value has remained the same, if you plug in a different y value, the x is not going to change. And that simply means that you could fold your paper along the x-axis and the top part of the graph would fall right on top of the bottom part of the graph. All right, the last one is looking at the symmetry with the origin. And what that means is if you have your point xy, then that means that the point where you take the opposite of your x and the opposite of your y will also be a point on the graph. And to look at this, an example would be this type of a graph here, where this point may be up here in the first quadrant, where you have your point xy, and then that means that xy is a point on the graph. If it's symmetrical with the origin, then that also means negative xy. Well, negative x, negative y would be in the third quadrant down here, and this would give us the point negative x, negative y. And one way to think of this is, imagine if you were to think of this almost kind of like a pinwheel. If you were to hold this graph kind of here at the origin, and imagine spinning this graph around with this like a pinwheel at the origin here, then this part of the graph up here would rotate around and fall right on top of this bottom part. And the bottom part of the graph would rotate around up here and fall exactly on top of the graph in the first quadrant. Okay, so let's look at a graph here where it says we want to find the x and the y-intercepts, and we also want to check for the symmetry and look at the graph. So we have the equation y equals 16 minus 4x squared. So I'm going to look at this. First of all, I want to find our x and y-intercepts. So to find the x-intercept, I'm simply going to let y equal 0. Remember before we said that if you're looking for the x-intercept, then you're on the x-axis, so therefore your y value must be 0. So if I plug 0 in for y, we have 16 minus 4x squared. Move over the 4x squared, so we end up with 4x squared equals 16. Divide by 4, x squared equals 4. And now we must take the square root of both sides, and remember when we do that, that's going to be plus or minus. So x equals plus or minus 2. And it's very important that you remember when you take the square root, you're going to get the plus or minus, because here you end up with two x-intercepts. You have negative 2, 0, and positive 2, 0. And then if we look for our y-intercepts, we're simply going to let x equal 0. So we would have y equals 16 minus 4 times 0 squared. So therefore we're just left with y equals 16. So we would end up with 0, 16 as our y-intercept. And if we look at this graphically, and let's see, I'm going to adjust this a little bit. We have our x-intercepts, which would be at negative 2, 0, and at positive 2, 0. And we have our y-intercept, and I'm just going to say this is all the way up here at 0, 16. And if we look at the graph, and hopefully you can remember this, or if you've had this before, with this is going to be a parabola. If you don't remember, you can always pick some other points using your chart like we did before. So you could just make a little XY table, and you could pick other values. For example, you could pick negative 1, negative 3, positive 1, positive 3. You could pick some other values and find your points. And I know that this graph is going to be our parabola. It's going to go something like this. Okay. And now, what can we say about the symmetry? Is this symmetric to the x-axis? Well, hopefully, obviously, if we look down here at the x-axis, it is not symmetric with the x-axis. But what about the y-axis? If we were to fold this graph on the y-axis, would the points fall on top of each other? So really, if we were to fold this here on the y-axis, this point here would fall right on top of this point. This point would go on top of this one. And of course, if we look at our x-intercepts, this point would fall on top of this point. So we could see that every single point when we fold on the y-axis would fall right on top of the other point on the opposite side. So this graph then is symmetric with the y-axis. And we have x-intercepts of -2, 0, 2, 0, and y-intercept at 0, 16. Now, I want to take this same problem where we have the y equals 16 minus 4x squared, and I want to show you how we could actually use the calculator to find your intercepts. So if you go to your calculator, again, we would go to y equals, and we would type in the equation 16 minus 4x. And for the square over here at the left, you just hit the little x to the 2 button, so that gives us 16 minus 4x squared. And if I hit graph, we see the parabola. Notice here it goes all the way up and it goes off of the screen, so that means we have to adjust our window, and that's because this window is going from -10 to +10. So if I go into the window, I know that I have to make my y maximum greater than 10. And based on what we discovered before, we know that the y-intercept was 16. So we have to make this at least 16 or greater. And I'm going to go a little bit higher, so I may type in 20. So then if we look at the graph, we will see the entire parabola here. We can see the very top of it before it comes back down. Now here we want to identify your x-intercepts and our y-intercepts. Well, I'm going to start with the y-intercept, and to do that you're going to hit your second function and trace. So if we go second function and trace, then number 2 says 0. I'm sorry, number 1 is value. We're looking for the y-intercept. So number 1 says value. If we click on that, it allows you to type in your x value. Well, if we're looking for the y-intercept, we know that the x value is 0. So if I type in 0 and hit enter, it's going to show me the y-intercept is 16. It shows you in the bottom right corner, and it also shows you with the flashing cursor where the y-intercept is located. All right, so now if we hit second function and trace, let me try that again, hit second function and trace, and again we hit second function so we can get to the calculate part, and we want to calculate now the 0, so I'm going to select number 2. Now when we say we're going to calculate the 0, that means we're finding out what makes the equation 0. So in other words, we're plugging 0 in for y. Now the way the calculator does this is it wants to find out where does this graph cross the x-axis, which would be our x-intercept. Notice the calculator says what is the left bound. Well, we know that over here we have the graph crossing the x-axis, so we want to use our cursor key here and move the cursor, hit the left arrow until we're to the left of this point. So now the cursor here is to the left of this point, and I'm going to hit enter, and then it puts a little triangle up here at the top, a little arrow, and then it says right bound. Well, that means I want to move to the right of where the x-intercept is located, because we know it's located right in here somewhere. And then we hit enter. Now what we've done is we've told the calculator we want the calculator to look between these two arrows for where the graph is going to cross the x-axis. Well, the calculator says now guess. Well, you want to move your cursor close to where it crosses and simply hit enter, and it's going to give you the 0. In this case that would be the x-intercept. X is -2. And if you want to find the other one on the other side, you would go through the same steps. You would go second and calculate, and we want to do number 2, and now it says left bound, so you're going to move the cursor over here close to this point. Now we want to keep it to the left of it, so I'm going to stop here, hit enter. Now it says right bound, so we want to move to the somewhere to the right of this point and hit enter, and then guess. We're simply going to move it close to where it crosses the x-axis and hit enter, and we get our x-intercept to 0. And if there's other places where it crosses, you would go through that same process. All right, so now I do want to point out one other option you have here. This is the best way going into this second and calculate. Now, if you simply hit the trace button, that allows you to trace the curve by simply hitting your arrow keys. Now, if you notice here, the cursor, as you hit this arrow, your cursor jumps along and your X kind of changes randomly. So you could guess to where this is going to go to the Y. And in this case, notice here we're getting close to, and actually this one gives it to us in this case. It says when X is 0, Y is equal to 16. But sometimes it's not going to give you that exact number when we go through the second function and calculate. So notice here, if I try to get close to the x-axis, it skips over it and it doesn't give us the exact number. So that's why it's better to simply go to second and calculate. Now, sometimes another option you could try is if you hit zoom, and then if you look at number 4, it says zoom decimal, number 4. What that does is now that obviously it adjusted our screen, but if we hit trace, I want to show you what happens, and I'm going to move my cursor over here to the left. Notice as I'm hitting this trace button now, and I'm hitting my cursor key, notice my X value is changing by 1/10 of a point. So that way, that may get you a little bit closer, and notice here I do end up with -2, 0. So there's a couple options you have with using your calculator, and I know this seems really complicated at first, but if you practice this a few times, hopefully this will become easier for you to calculate. All right, so there's an example of using your calculator with setting those left and right bounds to find the x-intercepts, using the value to find the y-intercept. All right, we have another equation here, y equals the square root of 2x minus 1. Now, of course, at this point, we could go back to the calculator, but I want to start looking at these examples using just our own skills. So we want to find the x-intercept. So once again, we're going to let y equals 0. So we're going to have y equals 0. So that's going to be equal to 2 times x minus 1, and of course we're going to take the square root. So now how do we solve for this? Well, we're going to have to square both sides of the equation to eliminate the square root. 0 squared is still 0. The square and the square root cancel, so we're left with 2x minus 1. And if we solve for x, we have 1 equals 2x, divide by 2, x equals 1/2. So therefore, we have 1/2, 0 as our x-intercept. And if we want to locate the y-intercept, we're simply going to let x equal 0. So we would have y equals the square root of 2 times 0 minus 1. And 2 times 0, we get 2 times 0 is 0. And then 0 minus 1. What happens here? 0 minus 1, be careful, we end up with a -1. Can we take the square root of a -1? And the answer is no, unless we go into imaginary numbers, and we'll talk about that a few chapters from now. And what this really means here, this is not a real number. It turns out to be imaginary, and that means there are none. So the graph will never cross the y-axis. Now let's look here a little bit closer. If I said, what is the, this is a reviewing a little bit hopefully, what is the domain for this particular equation? Well, if you don't remember how to find the domain of a square root equation here, then what do we know about the square root? We can only take the square root of values that are greater than or equal to 0. So that means this whole quantity, 2x minus 1, has to be greater than or equal to 0. So if we take 2x minus 1 and set that greater than or equal to 0, we solve for x. So then that means x has to be greater than or equal to 1/2. So that means we cannot have any values that are less than that. Otherwise, we're going to end up with a negative, just like we did here when we were trying to calculate the y-intercept. So if we were to look at the graph of this equation, and again, if you pick points, or you could use your calculator, I'm just going to go ahead and tell you the graph of this equation is going to look something like this here, where if this is 1, then here we have 1/2. We're going to start here at 1/2, and the graph is going to curve this way. So we're ending up with kind of like half of your parabola laid over on its side. And you notice here we do have our x-intercept here at 1/2, and clearly this graph will continue to go up, so therefore we will not have a y-intercept because the graph is not going to come back and cross the y-axis. And again, we said our domain here, our x value has to be greater than or equal to 1/2, so it's impossible for the graph to cross the y-axis. And once again, you could experiment as we did with the previous example. You could go to your calculator and type this in and see if you can identify your intercepts. Now, the calculator may have a little bit of a hard time calculating the x-intercept with this problem because notice the graph does not go past the 1/2. So you actually may have to do this one by hand for the x-intercept because there's no left side of this point. So you may have a hard time of the calculator trying to give you the 1/2. And of course, it's going to give you an error when you try to calculate this value when x is 0 because, again, 0 is not in the domain. So even though the calculator is a nice little tool to use, sometimes with examples of this type, it may not give you the answer that you're looking for because you're going to have to be able to calculate this on your own. All right, here we have another example. Y equals the negative, or we could read this as the opposite of the absolute value of x plus 10. So once again, we want to identify the x-intercepts and the y-intercepts. So if we try to calculate the x-intercept, then once again, we're going to let y equals 0. So we have 0 equals a negative absolute value of x plus 10. And if we multiply both sides by a negative, we're going to get negative 0, which is still 0, equals absolute value of x plus 10. So we wanted to eliminate the negative here. Well, now, do you remember how to solve an absolute value equation? Well, to do that, we're going to take x plus 10. We can drop out the absolute value and set that equal to 0. And then we're also going to take x plus 10 and set that equal to the opposite of 0. Now, because this is 0, we're going to end up with the exact same number because 0 is neither positive or negative. But if this happened to be another number other than 0 over here, this is how you would set this up. So x plus 10 equals 0, or x plus 10 equals a negative 0. So if we solve for x, we obviously will get x equals negative 10 and x equals negative 10. So that tells us we have an x-intercept at negative 10, 0. And if we want to identify our y-intercept, we're going to once again let x equal 0. So we would have y equals the opposite of 0 plus 10. So y equals the negative of the absolute value of 10. Now be careful, I know people that make a lot of mistakes here with the absolute value, but here we're taking the absolute value of 10, which is a positive 10, but the negative on the outside makes it a negative 10. So therefore, our y-intercept is 0, negative 10. And once again, you could use the calculator to look at the graph, or you could make your little chart for x and y and you could plug in values for x and solve for y. And I will point out the graph of this equation, and some of you may know this. If we look at the graph, we know that we have an x-intercept at -10, 0. So if we go over here to -10, 0, we have an x-intercept. And we have a y-intercept at 0, -10, so we're going down -10 on the y-axis. So we know that we're going to connect these 2 points together. And if you were to pick some other points less than the -10, if we go over here and we were to pick other points here, this is why it's important to pick not only positive values for x, but also negative values for x, because your graph then is going to have this sharp V shape just like this. And anytime you have absolute value, it's always going to have a sharp V, whether it's going down or opening upwards. Alright, so hopefully now you have a little bit better idea of how to identify your x and y intercepts, as well as your symmetry with the x-axis, the y-axis, and the origin. And the next video we will look a little bit more at some examples of identifying symmetry with the x, the y-axis, and the origin.